Thanks everyone for sticking around following ACES. I'm Michael Dolan. I'm a color scientist at Imageworks, and I'm the current chair of OpenColorIO project through the ASWF. So our agenda today, I'm going to give a brief update on the overall project, kind of our transition into Academy Software Foundation, and how that's gone, and some of the updates that have come as a result of that to our code and to our infrastructure. And then Doug Walker and Patrick Hodoul will cover some of the OpenColorIO version 2 work that's been going on, which is, I'm sure everyone's excited to hear about that. And then Mark Boorer from ILM will cover some work he's been doing on a new companion project to OpenColorIO called OpenColorMath, and then we'll have some time for discussion and Q&A at the end. So so I said I'm going to give a brief project update. So as you're probably aware, OpenColorIO, we joined the Academy Software Foundation this past year. It was a unanimous vote back in January to join, and that has sparked a lot of discussion and growth for the project and sort of reorganization of a lot of our structure. So one of the first objectives as when we became Academy Software Foundation project was establishing technical steering committee, which we have pretty good representation in the industry on that. I'll point out those names briefly. We meet weekly for a TSC meeting on Mondays. It's public. You're welcome to join if you ever want to have input. Part of the handoff from Imageworks to ASWF, so our license remained the same. We didn't change any of that, so nothing too scary. We moved our mail lists to the ASWF. If you were on them previously, and you're probably on the new ones. And nice thing is with the new mail list system we have with ASWF.io, we also have calendars and wikis and other things for to kind of aid in community discussion. We'll be moving the repos soon to the Academy Software Foundation GitHub account. It's currently still in Imageworks while we were working out some remaining issues before we were able to move it. Also, so if you look in our GitHub, so part of joining ASWF is really establishing a better governance structure and our policies on everything from contributing, governance, security. There's also a project charter and new CLAs. So all of that is in our GitHub repo. Please reference it. It's a great way if you're interested in contributing or learning more about the project. Those are a great place to start. So one of the things we've been working through this last year is when you join the ASWF, you become an incubation project, which means you're a part of the organization, or the foundation, but you have to kind of, work through some objectives before you become an adopted project. And so we have been working hard at that this past year. One of the steps we completed for that was achieving our Core Infrastructure Initiative badge, which is a program sponsored through Linux Foundation, which basically just makes sure that our code is following good protocols of security and testability and all the things that make software, everyone be comfortable using it in their application and in their facilities to make sure that we're following best practices. So we've achieved a passing status on that badge. And then the other thing is we have to pass a license scan before that was sort of the blocker with us moving our repository to the Academy Software Foundation is passing a license scan. And I'll talk a little bit more about sort of what we had to do to solve some issues that were in our repository in a little bit, but the issues that we did have been solved. So all the requirements for us to become an adopted project have been fulfilled, and so we'll be up for a vote soon to become the second adopted project following OpenVDB. This is our technical steering committee. So I'm the chair. Doug Walker is our chief architect, and then Sean Cooper at DNEG is our ACES TAC rep. So he's sort of our person to be our official representative with ACES. And you can see we have representation from ILM, DNEG, Imageworks, Foundry, Autodesk, and Framestore. And we're open to other ideas of people in the community who would want to participate. So please reach out. Our meeting notes are all on a GitHub repo, so you can see what we're talking about, and this link will have our schedule. These slides will be posted to the OCIO mail list in Slack following this, so don't feel like you have to take notes. You can get all this info. So one of the big things we've been tackling in our incubation process, along with OpenVDB and OpenEXR, is restructuring our CI and build and all the infrastructure that makes OpenColorIO. And one of the goals for ASWF this past year was to get all these projects on more of a uniform continuous integration platform, and so that we all kind of are working the same way and can share ideas. And so there's been a ASWF CI working group that we've all been a part of, discussing these things between the projects and collaborating on solving them. Before we got there, though, thankfully Mark Boorer kindly restructured our repository and modernized our CMake, so we're in a good place there. And then following that was our CI work with the other projects. And so part of that is as all the projects in ASWF together, we agreed that Azure Pipelines was the right approach for our CI, primarily because it has full cross-platform support, Windows, Mac OS, and Linux. So we have successfully moved our entire CI system to Azure, and is working on all three platforms in one place, which is really helpful for testing our builds. And also, one of the big things behind Azure that was of interest to us is that you can hook up your own machines to run builds on, which will allow us to support testing our GPU functionality. A big part of OpenColorIO is having a GPU renderer, which is something we can't currently test in CI. So that's a big thing we want to solve. And so some preliminary work to test that has been done, and that's future work, is to actually get that integrated into our CI. Part of the working group was some of the projects together. We've created a VFX reference platform implementation Docker images. Essentially it's a hierarchy of Docker images that inherit each other, that build a common VFX reference platform image and we tag it per year. And so there's like a base image, and then a common image inherits from that, and it has all the dependencies that all the ASWF projects rely on, and everything is adherence to the strict spec of VFX reference platform. And then each of the individual projects has an image on top of that. So OpenColorIO, we have a Docker image which is available to anyone who wants to have a easy way to build and test the project. And all our Linux CI is using that Docker platform now, which is great. And so as we move towards VFX Reference Platform 2020 and Python 3 and all these things, we'll be able to be really efficiently testing it, and everyone that's working on their third-party, all the companies that are writing software and sticking to the VFX Reference Platform spec will know that our stuff will work. And then the other side of it is we implemented Sonar Cloud for static analysis, so we could really test our code and make sure that we're following good security practices and code quality. And we've already had a number of pull requests towards resolving some of the issues that Sonar Cloud has helped us find in our code. So I mentioned license scan earlier. The reason we haven't been able to move our project over to the ASWF GitHub account was because, if any of you are familiar with OpenColorIO repo, we've had a lot of our dependencies embedded in archives in this directory called ext. And that was there to make it so that if anyone wanted to build OpenColorIO, you could just clone a repo, just build. You didn't have to worry about pulling dependencies and building everything else. So that was really convenient, but it presents various problems because some of those projects don't have FOSS compatible licenses, which is a requirement of all the Linux Foundation projects. So I've just finished some work, or we're still in progress on kind of completing it, where we basically have stripped all those third-party dependencies out of the OpenColorIO repo. So now if you clone our master branch and try to build it, it's going to look for those dependencies on your system. So you can point OpenColor, you can point CMake towards where your dependencies exist and build. But one of the objectives we wanted to tackle with that too is that because people have grown so used to building OpenColorIO and it's very easy to just clone and build, we wanted to still be able to kind of support that ease of build for users. And so we rewrote a lot of our CMake find modules so that if you don't have the dependencies on your system and if you don't feel like building them, there is a new option, OCIO install ext packages, which will actually clone those upstream GitHub repos, and it will build and statically link all the dependencies at build time automatically. So we're trying to still support that kind of ease of build, but for facilities that want to have more control and, and use their own stuff, that's supported as well. Just highlight this year, we did release OpenColorIO 1.1.1. And that was primarily just a bug fix build, but as there was an announcement made recently that Nuke 12 from Foundry will be using that primarily because it fixes some bugs we had with default view and display handling. So that release has been up for a while, and we are in discussion as to whether or not we'll do another point release bug fix release in the near future, which more than likely there's always a number of pull requests that we could backport from our master branch to the RB 1.1, and we're discussing that. We're open to input there as well. And then also the 1.1.1 opened up compatibility with newer versions of OpenImageIO, which we had versions 1.9 and newer implemented some C++11 functionality, which was incompatible with the way our apps were being built previously. So now you can build the OpenColorIO apps like OCIO Convert and all the apps that we supply. Those will build with newer versions of OpenImageIO, which is a good thing. Tomas couldn't be here, but he has been working on the ACES 1.1 OCIO config, which is it's currently available in his fork of the OpenColorIO configs repository, but he couldn't be here, but he supplied us some information I could present on kind of talking about some of the things that's tackling. Of course, a lot of you are aware of the changes in ACES 1.1, but it adds support for the single stage tone scale output transforms, for the blue light artifact fix LMT that was discussed in the ACES meeting, and the unnecessary white space in LUTs removed. So a lot of the LUT files that were bundled in the earlier versions of the ACES OCIO config had a lot of white space prior to the numbers in the LUT, and which was just kind of taking up space in the files. So that has been kind of reduced to just be a little bit more efficient. And then he implemented a post process after the LUTs are generated, which will go in and remove any nans and replace them with zeros, which will help Nuke not complain about that and other applications that don't like to have nans and LUTs. The precision of the LUTs has been increased. There's now inverse versions of a lot of the transfer function LUTs, like the linear to sRGB, there's sRGB to linear, goes both ways for higher round trip precision. And then a big one I know for us is there's a new log2 shaper. The previous shaper had a limited domain it could support, so if you had really really saturated colors and overexposed areas, you could encounter clipping issues, which would diverge pretty greatly from other implementations of the ACES ODTs. So the new shaper uses the same ACES-CC domain, negative 7.25 to positive 10.27 stops, and so that should resolve a lot of those issues. That's it for me. I'm going to hand it over to Doug and Patrick to talk about OpenColorIO version 2. Thank you.
Thank you, Michael. Actually, before we get into OCIO v2, I just wanted to mention that the big change from last year, for those of you who were here at the Birds of a Feather, is that we're now part of the ASWF, and from my point of view, that's a great thing. It makes it easier to contribute to the project. It makes it easier for you to find out what's going on with the project and track the progress. But it doesn't come for free. As Michael was going over, there's a lot of things in terms of adopting best practices and so on. And it was Michael actually who did the lion's share of that work. So I just wanted to make sure that we recognize Imageworks and especially Michael for taking that on, because it was definitely a lot of work. So on to OpenColorIO v2. So I'm Doug Walker. For those of you who don't know me, I'm the project lead for OCIO v2, and I'm also serving as the chief architect for OpenColorIO on the technical steering committee. I'd like to introduce Patrick Hodoul. So Patrick is the lead developer on the project. For those of you who don't recognize Patrick, you probably would recognize his avatar on his pirate avatar on GitHub. So if you've ever been on GitHub and wonder who's checking in all of those OpenColorIO, who's the pirate that's checking in all those OpenColorIO features, it's now you know. Although I noticed you changed your avatar to.
Yeah, I recently changed, so you can recognize me.
You can recognize him, yeah.
Face is perhaps not a good thing to have.
This is ASWF, you know. There's no more messing around here. So, so we've been busy since last time we presented at SIGGRAPH last year. So Autodesk has 3 full-time engineers working on this. So in addition to myself and Patrick, we have Bernard Lefebvre back in Montreal, who's been working with us. We've merged about 100 PRs since last SIGGRAPH, 68,000 lines of code approximately added, increased the number of unit tests from 85 to 709 so far. And we're having monthly V2 working group meetings. So for those of you who are interested, we have these on the web via Zoom. You're welcome to participate. I'll give you the details for how to join that at the end. But we present the work that we've just completed and the work that we're about to start, and we've gotten a lot of great feedback from people who have participated in that.
Just to mention a little bit about the development process, but before, the number of unit tests is really a critical point for us because it's a way to guarantee some kind of quality. It does not mean that before it was not working, that's not at all, but just one day we will have OCIO V2 ready, so it will be something to check to see what is the code coverage, what are the unit tests, so that we can guarantee a level of quality for you guys, which is extremely important. And extremely important for us also, as Maya guys. Okay, so development process. So after a lot of discussion and tries, we now have a way to work which is efficient for everyone, so efficient for us so we can make good progress, but also efficient for the community. So you have time to review or comment or post question or whatever. So mainly what we have is anytime there is a pull request, we require 2 reviewers. Oh, sorry. Anytime there is a, yes, far better, yeah. Are you listening what I was saying before or just sleeping, guys? So anytime there is a pull request, we need to have 2 reviewers, and we put also a deadline, so it's not too long for us to make some progress. For normal, I would say normal and big pull requests. Unfortunately, we try to limit big pull requests, but it's not always the case. We are doing a huge groundwork to be able to implement all the features you will see. And this is not one line of code, I'm sorry guys, but for very small, we accept 1 and it can enter quite fast. We also encourage everyone to look at what we are doing, so to comment, whatever comment it is, it doesn't matter, just to have your feedback. So, and also after a little bit before the 2 weeks, there is anytime I try to put something, a reminder to everyone so you can have a look, because I understand that everyone is really busy, so sometimes it's good to have a reminder on that. So for us, it's a good improvement. As you see, we merge a lot of stuff, and because we based on the amount of work we have to do, we have to speed a little bit, so we try to find a good balance between the 2.
Right, so for those of you who were here in 2017 at the Birds of a Feather, we presented our proposed feature set for OpenColorIO V2. There's a 16-page document that we published to OCIO Dev. We got a lot of great feedback on that. So for those of you who've been tracking the project, you've seen the list of features before, so I'm not going to go through these in any great detail. We did that in prior Birds of a Feather sessions, but just wanted to give you a sense of kind of where we are on the various features. So this is kind of giving you a sense. These are not all the same amount of work to implement, but nevertheless, it's if you want to draw the conclusion that we're a bit more than halfway through the project, that would be a fair conclusion to draw. So here is the release plan for OpenColorIO V2. So our project estimates that Patrick and I have done indicate that we should be feature complete by SIGGRAPH of next year. For those of you who have seen the VFX reference platform, the draft has been out for a couple of months now. The quote for next year's reference platform is 1.1.x with V2 in calendar year 2021. So we feel that feature complete by SIGGRAPH next year makes sense. It would allow products to start beta testing Q3, Q4 of next year, stabilizing and bug fixing during that period with a stable release of the library by the end of next year and products shipping in hopefully the start of calendar year 2021. So this is a major upgrade, and we felt it was important to give people good advance notice so that they can plan this into their development schedules. So in terms of the compatibility and the amount of work that's going to be involved to transition to OpenColorIO V2 from a user point of view, if you're a config author, V1 configs are fully supported, so those should just work. There are new features that are being added, and to take advantage of those, it will require using, bumping the version in the config to version 2. The syntax is the same. It's basically just adding optional new features. If you're a software developer, the API changes vary depending on the area. So for the GPU API, it was necessary to make substantial changes in order to bring the GPU renderer up to the same level of quality that the CPU renderer provides. So there are some large changes in that area. For the CPU API, we made some minor changes. We wanted to provide direct support for integer pixel formats, provide more optimization options, and so forth. So there are some minor changes, but very simple to adapt to. And of course, there will be new API calls for new features. All of the work is being done in the master branch. So those pull requests are going into master. You can, check the changes in the API. At the V2 working group meetings that we have every month, we make a presentation that kind of goes through the changes to the API. So, and we post those Zoom sessions, the recordings of the Zoom sessions online. So that's the best way of kind of tracking the feature progress right now.
If I can add something, just to mention that we try to minimize the amount of changes because we would like that it's easy for developer to integrate the OCIO V2, but sometimes we have to because we enter new features, etc. And the philosophy we following is that it will break, but you will not have side effect. It's working, but partially working. So for the OCIO config, it will work as is, and for the API, if there is a change, you will have a build break and an easy path to change. So for you, it will be extremely clear what to do, but it's extremely important for us.
Right. So last year we did a demo. This year, in the interest of time and trying to leave more time for questions, we're just going to run through a couple of the new feature highlights. So actually, do you want to cover the...
Yeah, okay. So that's one of the major work we merged recently in OCIO, in master, OCIO V2. So because we have the request to support more bit depth, so now with the API you can have that. And we have also channel ordering. It was already supported, but it was quite it requires a lot of knowledge about how to do that. But in fact, what we propose also is there is a small utility library, which is outside the library, which will help you to move from the OpenImageIO file spec directly to the OCIO image desk. So it's one line, and you have the full support, native support. Okay, so that's really what we try to do. Is you have the for hardcore guys, let's say, you can do whatever you want, obviously, as it was before, plus a lot of unit tests to validate that, but this is another topic. But for any other people which would like just straightforward implementation, you use that helper, and it's really one line, so you have almost nothing to do. Also, we have added a new command line tool, which is not a tool to do something, but to validate the performance. Because as you will see, we introduced a lot of improvements, but it was everything was done in our context with our images, machine, and so on. But most of the time, you can have issue on your context, on your studio, in your pipeline, whatever, and you need to have tools to understand that. So I don't know if you remember, but we already add command line argument to existing tools, so you can have feedback, verbose feedback, or whatever is done, for example, when you do OCIO convert, when you display, and so on. And we will have OCIO perf, which is a command line tool, just to, you have your image, you have your config, you want to see what is the performance of that, you can run it, and you have numbers. So just to help you to isolate where the slowdown could be located.
Yep.
Okay, these are numbers we have now. As I said, it's based on our environment, so it's the reason why we just put increase. But as you see, we have increase even in floating code paths, which is quite good because it was already existing and already good. But we also have improvement in the integer code path, because before, one of the limitation, let's say, from OCIO, you have to load your image, convert to float, and do your processing and convert back to whatever bit depth you would like to have. And now we natively support that, and we use that to improve the internal pipeline. So we have quite a very interesting improvement. And also, this is not the last pull request. It's all the work we did during 1 year by adding new ops, new improvement everywhere in the code. So it's really a long-term work on that.
Right. But yeah, hopefully people would be pleased to see that we're getting between 3x and 9x performance improvements on the CPU path at the same quality level. So, okay, so another of the new features that we added has to do with the ACES output transform. And as Michael was saying earlier, Thomas Mansenkal has done some work recently on the ACES 1.1 OCIO config. Building on the work that HP did, along with contributions from a lot of the people in this room. And one of the things that Thomas addressed that Michael mentioned was that, you know, there have been various forum posts from people generally who have tried sending very bright colors through the output transforms, and they've compared it to the CTL and found that it doesn't match exactly, and posted on forums saying, hey, what's up with this? And so Thomas extended the shaper basically to try to address the problem with bright colors, and you know the issue with this is that we're kind of running up against the limitations of 3D LUTs. So 3D LUTs work great for film print emulations, where you're modeling something that has a limited dynamic range, but the ACES output transforms are designed to work with very high dynamic range, wide color gamut source material. So 3D LUTs are ultimately not going to be able to represent it perfectly. So what I'm showing here is sort of a visualization of the errors in the 1.0.3 config for the Rec 709 output transform using one of the standard ACES test charts. And Thomas has managed to improve this somewhat, but there's still some significant errors. And so and by the way, I have if anyone wants to see more details and compare with Thomas's work, I have that on my laptop. I could show you later. But the ultimate solution to this is not to rely on 3D LUTs. So we've added some new support for ASWF. We didn't have to code up the entire output transform or anything like that. It turned out there was relatively small amount of math that needed to be added. So we just added a few building blocks that allow us to implement the output transforms without needing 3D LUTs. And that reduces the error to basically an exact match to the AMPUS CTL. The other sort of ACES related feature that we added is support for the common LUT format. So we have now full read and write support for S2014-006, which is one of the documents that was published with the ACES 1.0 release a couple years ago. And as you, I hope, heard in the ACES Birds of a Feather, there's work going on now in a virtual working group. And J.D. Vandenberg has been doing a great job on that with help from Scott Dyer and others. So there's a CLF v3 on its way for this fall. And I encourage you to get involved in the virtual working group on that. We intend to support version 3 in OpenColorIO once it's published. So, we think that this offers up a lot of very interesting workflow advantages. One of the things about this format that's a little bit different from other LUT formats is the amount of metadata in the LUTs. So we're supporting the rich XML metadata that's in the standard, in the existing standard, which includes things like description elements, ID attributes, input-output, color space descriptors, and so forth. So you can both read and write that from OpenColorIO now. We've also added support for Autodesk CTF support format, which is common LUT format, plus the extensions needed to losslessly serialize any OpenColorIO transform into an XML file. So this is something that we think is very useful for debugging amongst other alternatives to be able, sometimes if you're trying to debug a config and you are going from one color space to another, there hasn't been an easy way in the past to kind of see under the hood what OpenColorIO was, how it was actually constructing that transform sequence. So now there's a way of doing that, and there's an OCIO write command line tool for producing the unbaked output. Okay, so in terms of areas to contribute, we'd like to encourage people to contribute and get involved, regardless of what your skills are, what your interests are, how much time you have. We'll find a way for you to help. So as a developer, we have a bunch of things that we're looking for. As a tester, we're looking for help, and also as a documentation writer, we're looking for help. So we have a Google group for the V2 working group. Please join that. And we're having a meeting tomorrow here at the JW Marriott in the Olympic 3 room from 12 to 2. And we hope you can join us.
Just one thing, sorry. I try to put some energy to maintain good first issue label. So anyone, whatever your level of expertise or whatever you want to contribute to, documentation, test, code, or whatever, you can check for that label in GitHub, and you will see a bunch of stuff to improve, which are quite small. And even you can ask questions. We are really open to have external contribution because as you saw, we have already a lot of work to do on our side. So if we can receive help from the community, it will be great. Thanks, Guy.
Yeah. Okay, and I just wanted to give a shout out to Autodesk for supporting this work, in particular the Maya and Flame teams for recognizing the value of open source software and making the investment to contribute to that. So thank you very much. And with that, I'll turn it over to Mark Boorer from Ireland.
Thank you. Okay. So for those of you who are, well, let's speak into the microphone. Yeah, thanks. All right, for those of you who were at SIGGRAPH in Vancouver last year, we kind of spitballed a few ideas about potentially extending some of OpenColorIO's math capabilities. There's a couple of things in the V2 feature set that include things like fixed transforms or, providing some industry standard math transforms out of the box, so you weren't going away and writing your own sRGB LUT just to have, simple conversions and things like that. And so we've been spitballing a bit on that over the last year, and so I'd like to just give a quick demo of a new library that we're hoping to accompany OpenColorIO to handle some of that mathematical stuff, and just give you a bit of a taste of what kind of features it would have, and gather feedback from the room here today to see, what direction we should go with it. So first, what is OpenColorMath? So it's going to be a new library complementing OpenColorIO. It provides both a C and a C++ API. It contains data types for describing things like color primitives, such as X, Y, Y chromaticity coordinates, cone response matrices, color space conversion matrices, things like that. At the moment, for a lot of color code, certainly at least in my areas of the world, you kind of just used a vec3 and pass it through all of the functions, but this is kind of hoping to provide a more type-safe, secure way of describing, well, this is a function that needs, an XYY chromaticity, so make sure you pass that instead of accidentally giving it, an XYZ coordinate or something like that. Another feature is that it contains a JIT-compiled mathematical expression evaluator. So for those of you who have kind of lurked on OpenColorIO for a while, a few years ago now, I presented an expression transform that we never actually ended up merging into the code base because it didn't quite fit, and it also brought along a few larger dependencies at the time. But I'm hoping that same kind of math and logic can find its way into this library as well and complement the features there. And there's some additional command line tools as well, just to give you a few extra things in your tool belt. So the core of OpenColorMath is yet another excellent YAML file. At the moment, it's just called config.ocm, and I'm kind of envisaging it just sitting alongside your config.ocio file. We could potentially talk about merging it as part of the OCIO config as well. It has a couple of sections, so I'm going to blast through the sections on the screen as well, but just to give you an upfront, there's sections for things like white points, for chromaticities of color spaces, for listing transfer functions, cone response matrices, and other random matrices that you might have. This is the first little bit. So this is kind of an example of what the white point section of that config file might look like. We're using YAML references. I don't know if I have a mouse cursor, do I? Oh yeah, there we go. So this little funny ampersanded syntax is a YAML feature called referencing. So in the config file, you'll often have a chromaticity coordinate that needs a white space, and rather than having to copy paste the same white space again and again and again throughout the file, you can use these reference names to reference other parts of the document. So in this case, we have just a few example random ones with XY coordinates. Then we have a section of the file for listing primary chromaticities. So here's a small snippet. I have an example config that is quite a lot more advanced. So these ones are all kind of industry standard color spaces, but you might find that you have your own in your studio and want to add additional color spaces to this kind of list. So you can see they're just simply named, and the library has a few features where it looks up color spaces based on the names in this list. We then have transfer functions. So this is the part that pretty much resembles the expression transform from a few years ago. So the expression language is very similar to sort of C or C++ with the same sort of operators and order of precedence and things like that. It has a couple of built-in variables. So for instance, if you're running a 1D LUT, you can use the value V to represent either R, G, or B as the LUT is evaluated on each of those planes. But otherwise, you can reference just the R channel directly or things like that. It has some built-in functions as well, like log and pow and sine and all those sorts of things that you'd expect to find in a mathematical language. and we can extend that as needed if people find that there's certain mathematical functions that they want. One thing I'll say is, so it isn't a programming language. So although we have support for sort of conditionals and sort of a ternary operator there, these are really meant to be short expressions. So if we have really, really complicated mathematical processes, it's probably not the best fit for these. But yeah, in the places where I've used it, this has been perfectly sufficient for handling most kind of 1D and even some 3D LUTs as well. And yeah, here we have to represent both a to and a from transformation for getting to and from those transfer functions. This bit's kind of a bit self-explanatory, but we support any custom cone response matrix if you're doing adaptive transforms. So the Bradford and Caddo 2 are here, and if by some miracle someone invents a new one tomorrow, you would just be able to edit this file and add them in if you liked. And the last one is kind of a get-out-of-jail-free card. If you ever have a matrix that you don't know any other information about, but you still want to be able to use it in your color chain, this lets you just put a matrix in. As long as you know what the source color space was, it treats the name of this as the destination and will know where to fit it in when it's building an op-chain to transform stuff. So just a very brief show of some of the C++ API and C API. I'm sorry for putting code on a screen that no one wants to read. Short bit of it is, in C++ land, there's templated classes and functions that, this is an example where you could paste in the names of some known chromaticities and what transformation you'd like, and then the end result will be a matrix that you can, express that transformation. And here's kind of the same program written again in C instead. So here I've got the types for describing the matrix class, rather than being templated, because we don't have templates in C, they're just underscore prefixed, or sorry, suffixed with the data type. So this is a matrix returning doubles, and there's a function here, calculate color space matrices, that's also taking doubles, and you can access the elements and print out your matrices. So yeah, I mentioned that there'd be a couple of command line tools with it. So one that I play with reasonably frequently in kind of when I'm building my own OpenColorIO configs is this sort of OCM matrix tool. And as you can kind of see from the command line here, all you do is you just write the names of the color spaces in. In my case, I also added a -- nuke argument so that it would just spit me out a nuke color space node that I can copy paste into nuke. But I also have another argument that spits it out in OCIO kind of config file syntax, so it's easy to copy paste it into an OCIO config as well. The idea is, though, that with this library under the hood, we could just do this kind of stuff in a transform in OCIO rather than needing to bake out matrices or embed matrices in the config files. So yep, that kind of comes to another tool we have, which is OCM LUT. So in a similar problem, I often, when I'm generating config files from scratch, we often want to write out 1D LUTs for various transfer functions that we have. So this tool also lets you just bake out any of the 1D LUTs or any of the transformations, either a lin to log or log to lin or whatever format you'd like. Yeah, so most of those parts are in and working. There's still some cleanup that needs to happen on the code, but I'm hoping to have it kind of uploaded and ready for people to play with within the next couple of weeks. This slide kind of has some future ideas. Well, it has the only one that I've come up with, which is to add an additional OCM expression node inside of Nuke. I don't know how many people use the Nuke expression node, but I find it a tiny bit limiting sometimes. So I'm hoping to, get a bit more richer syntax or some better features to be able to, use in an interactive way. Yeah, and ILM is hiring in all of our sites, so if anyone's interested, yeah, please visit our recruiting team or come have a chat with me afterwards. Thank you.
Thanks, Mark. Yes, now we have a bit of time for Q&A. Anything for anyone that presented?
I've got a question for Mark. Could you talk a little bit about the choice to use external configs versus potentially sort of hard coding some of the common color spaces? I know there's been a little bit of discussion about the need for something like this for things like USD that want to do sort of trivial color transforms for previs, and it's come up in the context of simple texture transforms. Just curious what the...
Yeah, so the idea is, I guess I should mention, this is kind of meant to complement. If we did decide to have some of these pre-baked and provided by OpenColorIO, that's still kind of on the roadmap and one of the ideas to have. It's just we wanted a system where if you were in a facility where you needed to either override that or change the way it worked or add your own transformations, we kind of wanted it to be all in the same ecosystem. Whereas I didn't want there to be a divide between, oh, these are the things that are built in, but now I need to make a new thing to, I don't know, to do my transformations that my company requires or things like that.
Yeah, that makes sense.
Cool.
Any last questions?
Yeah, as long as you're on that slide, so access to variables and constants. So you have there are certain built-in variables like you mentioned the V or the RGB, but no, can we store temp values in like user-defined variables, or is that beyond the scope?
It's not beyond the scope. So under the hood, the system that does the expression evaluation can take a dictionary of kind of like key values for assigning variables. I haven't quite worked out a nice, pleasant way to express that in a config file. There's other things too, like, yeah, technically, should you allow multiple arguments into your functions? So if you had things like, say, I don't know, the array log transforms and you wanted to pass in the exposure index, things like that, like, it would be nice to be able to express those in here as well. So yeah, those are all things that are definitely not out of scope, but I haven't quite thought of a nice way to present that and show it. But yeah, it's definitely not out of the question.
Any last questions? Cool. Thank you all for joining us and getting the update.